Hi everyone and welcome to Data Science Dojo and Seattle Data Guide's live webinar on what is a data engineer. My name is Nathan Pacini and I am the marketing manager here at Data Science Dojo, and I'll be moderating today's webinar. Our presenter today is Ben Rogojan, a data scientist and engineer working in San Francisco, California. He has extensive experience designing ETL pipelines, databases, websites, and other software products for startups and pre-established corporations. Ben holds a degree in Management Information Systems from the University of Washington and has a background in business intelligence and data engineering. Currently, Ben works as a data engineer for Facebook and as a tech lead in data science and data engineering for Acron, managing multiple clients and engineers to develop algorithms, ETL, and BI tools. Ben, thank you for partnering with Data Science Dojo today to discuss what is a data engineer and create a discussion about the different job titles in the data science field. Welcome.
Thank you. Thanks so much, Nathan. And thank you for everyone who's joined today to kind of hear, what is a data engineer? What we're going to be kind of going over today and why I kind of put together this webinar was I really wanted to talk about, kind of the differences between data scientist, data engineer, and all of these various kind of data titles that kind of get thrown around. And I also kind of wanted to open up the idea for some people who, might be looking at these various titles and being curious what they are interested in doing in the future, and by kind of providing what a data engineer is and showing what skills we use, what tools we use, what are our goals, things like that, kind of laying that framework to say, hey, maybe you'll be interested in being a data engineer, kind of hopefully maybe help you answer that question, like, hey, is that maybe your goal? Maybe you started wanting to do data science, maybe you like more of the engineering aspect of things. So that's kind of the purpose of this talk. Okay, so just as kind of a quick high level of what we're going to talk about today, we're going to start out just talking about like the goals of a data engineer. I really think talking about the goals versus what we use, like what skills we have, is a little better because it kind of gives people an understanding of what we do every day. I like to think about it like instead of, if you're a carpenter, you don't explain to people that you use hammers and nails. You tell people, you build houses, you do framing, you do, you wire houses and things like that. Like those are more of your goals, and that's more of what you do. It's not like focusing on the skills like Python and the ETL development. Then we'll kind of go into skills and talk about each of the big skill sets I think we use a lot as data engineers, talk about what data pipelines are, go into tools of a data engineer, talk about a little bit about the interactions that we have at work, as well as kind of impact we have. And then I think kind of the more interesting, or at least one of the more frequent questions I often get is, what are the differences between some very similar titles like data engineer, data scientist, business intelligence engineer, data analyst, and just kind of going through that so that, again, it kind of helps you understand the differences. All right, so what are the goals of a data engineer? And I think there's a couple big goals. One of the first ones that I think you'll find out if you start doing data engineering work is developing data pipelines. And this is kind of one of those skill sets that I don't think you pick up in most undergrads, because most undergrads won't teach you about ETL development, won't teach you about what a data pipeline is. So this is kind of one of those big skills that we have, which all it really is taking data from point A to point B, essentially. We'll kind of talk about this in the skill sets, but it's basically taking data from, we'll usually see in an operational system, and then moving it into something that can be analyzed by analysts, by data scientists, and that's kind of leading to the next goal, which is managing tables and data sets. So those pipelines end up populating some sort of sets of tables and data sets that are then used by data analysts, data scientists to make all of their insights, because basically you're pulling all this data from typically some sort of product. You can think like Google News. You're pulling all the information of what people are reading and how they're reading it, how long are they staying on certain articles or something like that, and then basically translating it into something that analysts and data scientists can use. And then finally, I think designing with the product in mind, which I think this one's interesting because it kind of comes on both sides of the product. Because as a data engineer, we pull data from a product that users use, again, like let's say Google News, and then we end up putting it into some sort of product that internal business people will end up using. So we have products on both sides that we have to think about. So we end up having to play an important role when it comes to what data is being tracked from the user side. And then we play a very important role in thinking about, okay, when we develop these products like dashboards, how are users going to use it? What questions are they going to be asking when they're using these products? So when we create that dashboard, will there be more questions that are basically asked after we provide the initial information? So do we need to change the kind of tables that we're making? Do we need to alter the data sets that we're making? Things of that nature. So it's kind of like thinking ahead on this product. It's like, how are people going to use it? What do we need to consider? How far ahead? How far ahead do we have to think about features that this dashboard will end up having? And so those are kind of like the high level goals that we have. And then the question becomes, how do we get there, which is basically the skill sets that we use. And just as a high level, there's the concept of data modeling, which we'll get into shortly, automation, ETL development, and again, kind of product understanding. So data modeling, this is kind of one of those concepts that for some people, again, you were probably taught, a lot of you, especially if you were either a CS major or an information systems major, you're probably taught a traditional relational database design, which is typically highly normalized. So it's typically at least normalized to what we call third normal form, which just allows the database to reduce redundancy of information and also act much faster when you're dealing with transactional data. So typically, data modeling involves taking data from a transactional system. So something that like deals with, like, you can think about it pretty easily from like banks or Amazon when you go buy something, right? Like you're not analyzing a huge amount of data at that time whenever something's happening. You're just literally saying, insert a row because I just withdrew $100, or insert a row because I removed $100, one or the other. And so it's just these quick transactions, and you don't want them taking forever. You want this thing to happen really quickly so that, as you're using, your Chase online, when you make that transfer, it's not going to take, 10 minutes for something like that to happen. The one problem is here with the relational models is that they're very that very much normalized format makes it very difficult for analysts and data scientists to use, because there's a lot of logic that goes into it. Oftentimes we in the data engineering world will complain about like the amount of joins you have to make, like to get some piece of information. You've got to join like 4 tables over just to get a single data field. And doing things like that is, 1, slow, and 2, just difficult for everyone to understand. Again, it's not very self-service. We talk a lot about that in the data engineering world. We talk about, creating data so that it's kind of usable by data analysts in the self-service kind of format, so they can just connect their Tableau dashboard to it really easily and, start building things really quickly. And if you've got a really complex model, it's very difficult. So we end up creating what we call data warehouses. And this definition is changing over time with new data storage systems like Hadoop and things like that. But the kind of concept in itself stays about the same. We end up taking this very normalized data set and make it a little less normalized. We start kind of denormalizing it, and we start developing what we call, typically they're like snowflake or star type models, and they really just have a central table that we call some sort of fact table, and they just act as the kind of main thing that we're representing. So in this case, a transaction. So that transaction is the main action we're probably going to be analyzing in the future, and we're going to be having all those questions on. And instead of having tables or information around that be 4 or 5 tables away, it's only 1 table away, and it's really easy to join to. And most people can kind of see, there's the location table. Well, it obviously connects to that location code, and it's very simple that way. Actually, the one thing, just saying that out loud, it would probably just be location ID and not location code. But so it's just about taking that data and remodeling it. So thinking, how do we keep the data from the original data set to this new data set and not changing what it says? Because it's really easy in this process to accidentally change things and accidentally lose information, or maybe duplicate rows or something of that nature. So data modeling is very important, because you need to keep the story, whatever that data said originally, needs to continue to basically exist in your future data model, your future data warehouse. And so that's data modeling. Next, we're going to talk about automation. And so automation I've kind of just used to basically group up a lot of the things that we do. So, data engineers do a lot of programming, but it's definitely can be a little bit different than what software engineers do. I think we're very more focused on automation, and so that changes a lot of the style and a lot of the basically patterns that we follow. We don't do a lot of object-oriented programming unless we're building more frameworks. Typically, our stuff is mostly focused on building what we'll call either tasks or something similar to that, where it's just doing a very isolated, each kind of maybe function, you could think about it, depending on what framework you're using. But each kind of task is just doing a very isolated thing. And then you have to make sure that each of those tasks are, one, timed correctly so that they're running at the correct time. Sometimes it can be, hourly, weekly, daily, something of that nature. So you've got each of those tasks running at the same time. And then you've got this other aspect of dependencies. So in automation, a lot of things are moving. There's a lot of moving pieces. And so you want to make sure that if table A comes before table B, or if task A comes before task B, that's somehow tracked. So when you're automating things and building frameworks that kind of manage all that, you have to make sure there's something that's keeping track, because you don't want, if table or task A is running longer than it normally does, you don't want to just hope that task B doesn't kick off earlier. So automation kind of involves a lot of thinking ahead and developing systems, whether it be through Python or PowerShell, and we'll get into that later. But however it's developed, that workflow is managed correctly, that things don't run out of order. That's kind of one of those risks you run when you start automating things, is it's really easy to not think about, oh, well, we'll just run this thing an hour after the task A, because task A only takes 30 minutes and it will never have a problem. And then you'll inevitably have a problem eventually, and then suddenly you're out of order, and maybe that table that you were meaning to load doesn't load, and now you've basically caused bad data throughout your system. Which kind of leads to the next point, which is failures, because in this world of big data, in this world of lots of big moving pieces and like thousands of moving pieces, like you look at a company that's really large, like I remember with, let's say, Amazon, like I remember probably interviewing with them 4 years back and then talking about how they were trying to manage all their ETLs. Like there's a lot of things that go on that can go wrong. And so you want to make sure that somehow those failures are captured, because they'll inevitably be things that go wrong, because some sort of product feature will go wrong, and so you might not have the data there, or something just breaks, or somewhere in the whole system inevitably something will go wrong. And so having some sort of notification system usually works great. This can be done in emails. This can be done in other kind of, like, if you've got systems that kind of connect to it, it might be automatically connected into tasks. So if you've got like a Kanban board type thing, you might just have tasks automatically get assigned as things fail. But something needs to kind of exist that keeps track of where things are and if things are failing and what needs to get fixed. And so that's kind of the automation portion. It's kind of this whole system design, programming aspect of our skill set. All right, next is ETL development. So ETLs, you can call them, there's another kind of concept called ELTs. You can also just reference this as data pipelines. It just stands for extract, transfer, or transformation and load. Basically, all you're doing is taking data from operational systems. So this could be Workday, this could be Lawson. For those of you who use Lawson, I've just basically put 2 different HR type systems up there. If it's more of a product, this might be something like MySQL or Oracle, but it's something where users interact with and is that operational database. And then basically each of those arrows kind of represents that ETL, which is pulling that data from essentially that operational system and moving it and piping it into the data warehouses. I've used, there's a lot of different tools we're using right now for data warehouses. There's definitely the older school tools. So I've used SQL Server, I've used, Oracle databases to kind of represent your data warehouse. And then there's more modern data warehouses that people are using nowadays, like Hadoop, Redshift, and things of that nature. But they all kind of act as the same place, which is, you're just using it as a place to store your data and format it in such a way that analysts can get to it. And then in that kind of whole ETL development we also kind of will do something that I like to call an analytical data layer, which is just where you start doing ETLs that do more than just extract data. They start actually doing things like aggregating data, maybe running some sort of metrics or algorithms on your data, so that way they can be easily fed into future dashboards. Specifically, once you've got data in your original data warehouse, it's probably very granular, and it's going to take a lot of time to run a lot of the metrics and models. So having that analytical layer and the analytical layer of tables just makes it faster, so that your users can get to that data really quickly and see their metrics and dashboards really fast. And then product understanding. So when I say product understanding, the products that data engineers make, specifically that we make, are either dashboards, tables, and data sets, and that's kind of our bread and butter. And so we kind of look at data as our product. So we have to make it in such a way that users can use. So if we're building data sets for, let's say, machine learning engineers or data scientists or something of that nature, we kind of need to understand how they're going to use it. We need to kind of understand what are their models that they want to build. Are we providing them enough information? Do we need to provide it at a different granularity? Which, when I say granularity, it's kind of just saying the level of the data. So we could, for instance, provide granularity just quickly at like customer level. We could provide granularity at like maybe the store level, which just tests to say how aggregated the data is. You can provide it even transaction level. So oftentimes, especially with, like, let's say, data scientists, they probably really want to see things at a transactional level, because they're going to really want to look at things at that granularity and probably want to aggregate things themselves. Whereas if you're doing a lot of metrics and dashboard development, you're probably aggregating things. You're probably creating data sets that are much tighter and much harder to drill down in, but they're much faster to use. So that's kind of the product understanding, is like, you kind of need to know, well, what's your data being used for? What are the questions you're trying to answer with this data, and things of that nature. So why do data engineers need to develop data pipelines? I think the biggest thing is we need to create data pipelines because it improves ease of access to data. Data in operational databases is very difficult to access. I mean, besides the whole aspect of, you shouldn't be running analytics on your operational database, but if you were to even make a copy of it and just straight copy it over, it's just very difficult to use. It's not really easy often to understand for analysts, and it's also often filled up with bad data. You'll often have sometimes duplicate data in that operational database, and it just needs to be cleaned up. It just needs to be easier for the analysts and data scientists to use it without having themselves to add a bunch of business logic just to get a clean data set. So our kind of goal is to create these clean data sets that analysts and data scientists use, that is really easy for them to just understand and also for them to trust. Again, we also just do that whole producing the analytical layers for dashboards, which just, again, makes things faster. As users need to use things, it doesn't make sense to have things really low level and then try to run all this metrics on them basically ad hoc. You want to basically think about that analytical layer prior and just have that dashboard touch that analytical layer rather than go through trying to drill down into the data right away. And then clean up data, which I kind of brought up in improving ease of access, which is just getting rid of things that maybe shouldn't be there. It's actually pretty common for things like either duplicate data or maybe test data or just data in general that shouldn't be there to kind of find its way into the product. So cleaning that out, sometimes you might even just be cleaning out, like if you're doing financial data, you might just be cleaning out the ins and outs. If you've ever done accounting, the kind of in-out approach that they might do, where they write a transaction and realize it was the wrong transaction, and then write a negative transaction to move that out. And maybe you don't care about that, and you don't want analysts to accidentally count that as a transaction or something of that nature. So just providing clean data sets so that they can know that every line that they're reading is an accurate line of data. Okay, so what are the tools basically that data engineers use? And I think one of the things that really sticks out to me as the tools that data engineers use is the pipeline frameworks that we end up using. And so this can come in a couple different flavors, but what they basically are basically things like I talked about, tasks, and they basically just make it really easy to break down tasks. Like, let's say SSIS. If you've used SSIS, is a really easy tool just to kind of like pull and drag and drop. It's more of like a GUI system. It's Microsoft, so it has that GUI feel that Microsoft usually has, where you're kind of just dragging and dropping. I'm just going to again call them tasks of things that you want to do. Like maybe you want it to automatically email you if something happens, and you can basically just drag and drop a task and set some parameters in that task. to who you want to email, when you want to email, why do you want to email, and you can really easily add basically dependencies and things of that nature in that pipeline. Informatica and Airflow are two other examples. Airflow in particular is kind of nice. So Airflow is Airbnb's version of basically a data pipeline management system. And it's actually really nice because it doesn't look at everything from an isolated point of view. It actually allows you to do, it creates basically a dashboard. If you've ever used Airflow, it creates a dashboard that lets you kind of track where your system is, what ETLs have run. It's actually really nice. If you haven't used it, I think it definitely makes it much easier because you can kind of see everything from a high level. SSIS, you'd have to do a little more to kind of set this up for yourself, whereas Airflow automatically has kind of a GUI that lets you see what's run, has it failed, what does that depend on that's failed, and things of that nature. So that's why Airflow is really nice. And it's also in Python. So if you need to write a lot more customized scripts, this is really easy, whereas SSIS is a little bit harder to write customized things. You can, it's just not as easy. And so that's kind of like the two sides of it. There's the side where it's SSIS, which is really drag and drop. Informatica has a similar feel, whereas Airflow is very like customizable. It's written in Python, so you can easily write scripts around it if you need to, and add utils if you need to, and things of that nature. The next really big skill that I see people need to use is SQL. SQL is kind of one of those interesting things because, with Hadoop and things similar to Hadoop with NoSQL, there was a moment, I think, where a lot of people assumed a lot more of our work was going to be writing MapReduce jobs. And there is that portion for sure. But due to things like Hive and Presto and other similar kind of layers on top of Hadoop, we've been able to kind of stick with SQL because I think for many people, it's one, easier to understand data through SQL versus MapReduce, and two, it's much cheaper to hire a data engineer that knows SQL versus having to hire someone that knows Java and manages Hadoop low level. So SQL is still this really big skill that you pretty much need as a data engineer. It's how we manipulate data. It's how we basically do those transformations. It's just really easy to use it, and a very big portion of the technical population knows it. That doesn't mean we don't do programming. So I mentioned automation. So things like Python, PowerShell, Linux, those are kind of the three automation. I put Java in there if you're doing like MapReduce work, but it really depends, again, which company you work for. But you'll definitely be doing something with Python, PowerShell, or Linux where you're just having to be automating things and basically using these scripts, kind of scripting languages to kind of develop a framework around whatever you're building. And some companies will test for it when you're interviewing, some won't, but you'll generally end up using it one way or another. And then finally, kind of another skill or tools that we use, I think, is a lot of data viz tools. So things like Tableau, D3, SSRS, et cetera. There's a whole kind of plethora of visualization tools. I think it leans more towards the Tableau side for most people because Tableau is so used, but we do a lot with dashboard development just because it is kind of right there and easy to kind of go from, building the data set to developing some pretty easy dashboards to look at. Tableau is the easiest. D3.js is kind of fun if you've used it. It's a little more painful if you're not a JavaScript fan, but it definitely allows for a lot more customizability. You can make some pretty cool visualizations. If you haven't ever looked at it, it's kind of fun to go look and see some of these D3.js kind of visualizations that exist online. Personally, I was introduced when I was at UW to it, and I thought it was a lot of fun. Tableau is just easier, so I usually recommend people prototype at least in Tableau before they try going too deep into D3, just because it can be painful. All right, so what kind of impact do we have as a data engineer is kind of my next point. So how does a data engineer make an impact? So I think the big thing is creating optimized pipelines. In this world of big data, and as data is kind of getting bigger and moving faster, it gets really tempting to write bad pipelines because it's easy. Again, with all these tools, it's really easy just to pull data in and run pipelines and run thousands of pipelines and not realize how much compute you're using. But as data kind of grows, it's really important for data engineers to really build efficient pipelines because it would seem like, as we're getting faster compute and better at computing, it would make sense that, we'd have to care less. But because data is also growing along with that, creating optimized pipelines is kind of important. And it's kind of one of the big things I think we do. Next is influencing. So I think we do a lot towards influencing what is built and what is analyzed. I think this goes for pretty much anyone in an organization, but especially, data engineers have a very close relationship with their data. So we kind of have a general idea of what exists and what can be built. At the end of the day, we know what data exists and we know what data doesn't exist. And so if someone were to come to you and ask you a question like, can we answer this question? You have a really big charge of like being able to know, yes, I can, or no, I can't, or what do we need to start collecting to build that thing? And so influencing, we kind of play that role because we know what exists, we know what's there, and we know what's not there. And then designing, that kind of is somewhat connected with creating optimized pipelines, but we do a lot of designing when it comes to things like frameworks and developing systems that either other data engineers can use, maybe some of the data scientists can use to kind of pull data easily. A lot of people are developing more and more, or are looking data more and more as a product and not just as this table that just has to be there all the time. And then finally, maintaining. So I think this is probably the least interesting thing that most of us have to do, but it's definitely one of those major skill sets that we need to use, which is just maintaining other people's pipelines and code that have come before us. Because at the end of the day, oftentimes, you'll have lots of infrastructure that's been developed prior to you coming on, and you'll spend most of your time making sure that's still running, making sure, if bad data comes in, you're cleaning it up, and making sure that those pipelines keep running. And so maintenance is definitely the least exciting part, I think, of most of our work, but it's definitely this big part of impact because, if things aren't running well, then someone's going to cry out. And so making sure that you're constantly looking at your pipelines and making sure that things continue to run, not just you're building new things. Okay, so that's all great, but what's really the difference between data engineer, data scientist, business intelligence? And so I'm going to focus first on data engineer and data scientist. And kind of like earlier, I talked about goals. I'm going to kind of focus here again. We kind of talked about data engineering goals being more focused towards building things and building those pipelines and creating tables and data sets. And I think data scientists, their goals are much more focused on, or they're not as much focused on engineering and managing data sets. And their focus is a lot more on answering questions, and specifically answering questions and analyzing things that either do one of two things, which is either reduce costs for business or increase revenue. And it really kind of breaks down to those two topics, because we can kind of talk about it, in a more nuanced way, where we might say we want to, improve customer retention, or we want to improve the amount of times a customer clicks, that buy now button on Amazon. And we want to figure out, does something impact that? Does the ad we show change that? And at the end of the day, it's more about, increasing revenue. That's kind of the goal. And the data scientists will focus on asking those questions. Well, what questions need to be asked? What hypotheses need to be posed? And data engineers will focus more on building the data sets so they can answer those questions. But again, a data scientist's goal is really analyzing things, thinking about what needs to be analyzed, what kind of questions need to be posed. How could we possibly, maybe it could go the other way. It might not just be improving customer experience. You might want to say, how can we improve employee experience? So it might be focusing internally, but you're really just trying to figure out how you can really move those two levers, costs and revenue, in a way that's positive for the company at the end of the day. I think for specifically now, if we were to go to business intelligence and data, specifically business intelligence, I think it's a much blurrier line. The BI field has kind of, I think, merged a lot into a lot of the data engineering field, just due to the fact that the skill sets were very similar to start with. So when it happened, when data engineering kind of became its own thing, a lot of people kind of started blurring that line. Originally, like Hadoop was, I think, a bigger thing, and specifically MapReduce with Hadoop, but with the kind of introduction of like Presto and Hive, BI people have been able to kind of step in the data engineering space pretty easily. And I also say that in saying the fact that, I've gotten, whenever you interview at some companies, they'll give you those study sheets, and I've literally been handed the same sheet for both the business intelligence position as well as a data engineering position at the same company. And so it really ends up being about the same one way or another. You do a lot of similar work, you do a lot of data modeling, you do a lot of ETL development. And so I often kind of see those as a harder split. Sometimes I think business intelligence can lean a little more towards the analyst / dashboard development side of things, but it is, I think, a blurrier thing. So I like data engineer just because it's clear to me that you're working on data, but I think they do a lot of the same work. Okay, so I think that is all. So we're opening up to questions, I think, now. So should I just, I think I saw a few questions. Should I just open up the Q&A here, Nathan?
Yep.
Okay. Okay. Okay, so one person asked, what is cron? So cron, I didn't really talk about those specific things. So cron is this thing in Linux that allows you basically to set up when you want to run things. I don't have it in front of me anymore, but basically it's kind of always fun to try to figure out what each of those like stars mean. So if you, in the picture, there's like all these stars, and each of those kind of represent how often you want to run something based on like day, month, and year. And then, so it's just basically something that lets you kind of set, you basically can, if you write like, okay, let's say you write a Python script, you can basically put it into cron, you can reference it into cron, and on that same line, you basically reference how often you want to run it. So you can have multiple things. It's basically, you can have like multiple lines, multiple Python files in cron that will run. Similar thing in Windows would be Windows Task Manager. And it does kind of the same thing. It's just more GUI focused. So that's why, so it's just easier to use on Windows versus cron, which is a little bit finickier. Because like I said, like I have to pretty much Google like what each of those stars mean, because it is hard to remember. Okay, I want this to run, on Wednesday at 3 p.m. and that kind of can be a little more finicky. So I think that's cron. I mean, I hope that helps you understand what cron is. Basically, it's a task manager. Does each pipeline only serve one analytical goal? In other words, do we have to make analytical goals before creating data pipelines, or the opposite? I think most of us like to do it that way, where it's like each pipeline is very isolated. Kind of going back to that whole dependency thing, creating kind of isolated systems, so that way, if you're trying to populate 5 different tables with one pipeline, you're just bound to have something go wrong in one of those tables. And so it's just easier, it kind of goes similar to like object-oriented programming, where everything, it does its own thing. And that way it's easier to debug. It really comes down to a lot of debugging and maintaining. And so when we build pipelines, we want to build things with maintenance in mind, and developing things for the future. So someone in the future needs to come look at this. If this pipeline does 10 things, they're going to have a really hard time figuring out, well, what went wrong, which task does what thing. So it just makes sense to have it very isolated, and think about, what is this analytical pipeline doing first before trying to like just build something the other way. Okay, what role does data architect play? So data architect plays typically at like really big companies. It's really easy to break this down much more. The role of like data scientist, data engineer, all of these things can be broken down much more. So I think there's an aspect for some data engineers that really is data architecture. It's that data modeling kind of step. At like, when I worked at startups, the whole concept of like data scientist, data engineer, like that didn't really exist. Everyone just did everything. Like you did your data architecture, you designed that system. So it really is about designing the tables, because how you design your tables really drives your product. So that's really a data architect's job, is to make sure that, hey, if we design this tables this way, one, does it represent the data correctly? Because it's really easy to accidentally design the tables incorrectly, and not just the tables, but the fields in the tables, because you've got things like changing dimensions, or slowly changing dimensions. So, which basically references, over time things might change for like dimensional data. So you might have something I like to think about, like let's think employees. Employees are very consistent data over time, right? Like an employee for 1 year might have one job role, like data architect, but the next year they might have, a data architect manager. So that's a changing dimension, but it's only slowly changing. And so making sure you capture that somehow. making sure you capture all these transactions. And that's kind of part of the data architect's role. It's like, how do we make sure this data is always representing what's happening? And so if we have a question, we can answer that. We want to say, how often do people change roles? We want to be able to answer that question. And if you're not capturing that data, because some people will just, if you just update this person's title and don't keep track of what they were before, you're not able to keep track of the information of, oh, well, did this person change? We don't know. We only update the data. We never keep track of the previous data. Or you might want to ask how often do people change roles? And if you don't keep track of the date that person changed and the previous date that they started, you're not going to be able to answer these questions. So data architects have to think about what questions are going to be answered or asked in the future, and does this data answer it? Oh, there's a lot of questions. Why do data engineers focus so much on developing algorithms when I haven't really, it's the same thing. So sorry, let me read that whole question. Why do data engineers focus so much on developing algorithms when I haven't had to really do that on the job? I think it's the same thing with software engineers, right? Like we have the same question when you're like, why do we focus on traversing trees and breadth first search and all these things when we don't use it? And I think at the end of the day, it's kind of like the GRE or SAT. You might not need those skill sets for school, but it's a standardized methodology of trying to figure out people's, where they are in their programming world. Obviously, again, like we rarely end up using this. Like if you're not gonna implement your own binary tree, you're gonna just import it. But yet they'll tell you to build one. So why? Or same thing with like merge sort or something like that. And I think at the end of the day, it's more like they have to use something to cut out people. And although they're probably cutting out like these people that are really good at programming or being data engineers, being software engineers, on average, they're not. And so they might be losing, 5 or 10%, but they need 5 or 10% of people that they should be hiring, but they need some sort of signal that says, hey, this person's worth hiring, or no, this person's not. And it sucks. I say it sucks because I don't like interviewing. I don't think a lot of us like interviewing, and it's a skill set that we just have to kind of bear with until people come up with a new thing. At the end of the tutorial, kindly let us have a real world example on GitHub or via email, which covers all that, so they know how the real world is and how to handle it. Just a little example or task. Okay, I can try working on that. Yeah, I can try working on that. It's not a question, but I will. What is the latest research area in big data science for postgraduate students? What is the latest research area? I guess I don't have a question or an answer on that, mostly because I don't do research. I think, personally, what's interesting to me is that we're still really relying on data systems that are, I think it's like 60 years, or maybe not 60 years old, but like, I don't remember when Oracle was developed in the original relational database, but we're really not, the concepts that we've used have really been the same concepts for the last, I don't even know, 50 years. So I'm really curious, I think, to see that if we can start figuring out ways to maybe break away from that model, if there's better ways to store data and access data. But I don't know anything off the top of my head. For telecommunications engineer, which courses are good to pursue a career in this field? If your goal is to break into data engineering, I think the biggest things to focus on are SQL and I'd say Python in general. Those are kind of the big two skill sets you need. And then also, again, data warehousing. Like, you can go online and find some data warehousing class, or even just some YouTube. I'm sure there's plenty of YouTube clips on showing how to build a data warehouse and like what are the data warehouse concepts. And then again, combine that with some SQL and Python, and that's pretty much the basis that you need. As a software engineer, if I want to jump into data engineering, what steps do you suggest? Main challenges faced when started in this field? As a software engineer, I think the big thing you have to hurdle is SQL and data warehousing. So once you understand those two concepts, really the rest should be pretty easy. Software engineers have that benefit where I think you have a much broader skill set, and it's much easier to go into things like data science and data engineering because you have a good base, and it's really just about adding the specifics. If you want to go into data science, you can, as a software engineer, you can probably take a data science boot camp or something and go into that field. If you want to go and be a data engineer, you can pick up things like Hadoop and data warehousing and SQL, and that's really all you're going to need because you already have the programming side of it. And SQL shouldn't take you that long because most of what you need to learn in SQL you can learn pretty quickly, and data warehousing is more conceptual. So it's more about designing data warehouses and what does that mean, what does that look like, and that should be, again, pretty quick. They give us tutorial resources online for ETL, pipeline construction, and SQL tasks. I can try working on that. I definitely write some posts occasionally on Medium. I don't know if I have anything specifically on this. Mostly, I think recently has been focused on like interview prep. So that's been kind of the focus, but I can work on trying to develop some things more of that nature. If someone wants to become a data scientist or generally just get into the data science track, how should one start? I believe that it should be some people attending this webinar who would be in the undergraduate or starting, it would like to know about it. So data scientist, I think, is kind of interesting because I think what a data scientist is depends company to company, and it's also changed over time. There's definitely a portion of data scientists that you kind of need a PhD to do the work that they're trying to do and answer the questions they're trying to answer. But there's definitely another portion of data scientists that really have kind of fallen more into almost like a data analyst position. In fact, I know at Zillow, for instance, they ended up switching their data scientists to research scientists and their data analysts to data scientists. So they just kind of changed their titles. But generally, what you end up needing to do, I think a boot camp works great if you already have like software skills or some sort of good base. I have actually seen people go from boot camps to, I mean, Zillow is the example I give because I know someone that literally went from having an English major to a boot camp to working at Zillow as a data scientist. And so it's actually usually a pretty good practical methodology. That's just what I've definitely seen. Let me think. But overall, I think you kind of just need to fill in that gap. Like if you've got a good software background or a good analyst background, data science has kind of changed to where I think it really does fit for some people to be more of a kind of data analyst. And it really, again, kind of depends. If you work for a startup, generally I've noticed that a data scientist will be that master's or PhD because they need to do so much for that startup and they're the only person hired that is a data scientist. But when you work for a really large corporation and there's a lot of other data scientists, they'll just break down who does what work. So I think that it just depends where you want to do. 3, do you expect some kind of domain expertise data engineer, or as a fresher I can jump in this area? Yeah, so it's definitely like if fresher means freshman, it does help to have some domain expertise, but some of that kind of gets picked up on the way. I remember my first job out of college, I had no idea what a data warehouse was. I had no idea what an ETL was. And I just started accidentally doing those things because people would tell me, oh, I need to, you need to query this database and I need these answers. And I didn't realize, I'd learned about relational models and I was connecting to this data warehouse. And it didn't click to me right away that this is a totally different setup or system because you're still writing queries the same way. So as long as you kind of understand SQL, you can kind of get around in a data warehouse. I think most of the times people won't start out as a data engineer. They'll probably go into either being a data analyst or a BI engineer because there is this kind of gap where you're missing this understanding of what a data warehouse is and what an ETL is. And I was definitely missing it. And it definitely took me some time to figure that out and figure out that those things were even a concept. Because again, no one even taught that in undergrad. I don't know if anyone's undergrad teaches it right now, but there's definitely this gap of like data engineering concepts being taught because most people would teach you a relational database and no one will teach you what a data warehouse is in college. I've seen a lot of master's degrees, but other than that, you kind of just have to do it yourself. You kind of have to just get into a company where, you might be a BI engineer or something and then go into data engineering. You touched a bit on it, but which skills would you say are more important to being a data engineer in your experience, SQL or Python? I guess you could say SQL only because some companies won't use Python at all. Right, like I said, I was talking about SSIS, and that's kind of a tool that you use that's just drag and drop. it involves, no Python whatsoever. You're literally dragging and dropping like boxes, and you might be putting SQL inside them into those tasks, but you won't need to necessarily program. So that's why I think SQL is definitely arguably more useful, but I think you always kind of need something to manage the workflow of the data. And because even once you've created this SSIS task, something needs to call it, something needs to manage it. And so, yes, I say SQL is more important, but I think you need both either way, like some sort of language, some sort of programming language that you can automate your work with. Yeah. What do you think are good things a data scientist should know to work well with data engineers on their team? I think generally it's just about communicating and helping them understand what you're trying to do. I think one of the problems with when we're working with data scientists or data engineers or anyone in the tech field or anyone on like kind of a team, it's that empathy component from both sides needs to kind of be working. Both sides kind of need to understand what problems they're facing. Like as a data engineer, we have to work on being very transparent about what we're facing problem-wise to get data. And as a data scientist, there needs to be that communication of what are you trying to do? What questions are you trying to answer? And I do find that most data scientists are pretty good at this, because most data scientists will often be asked by some manager to ask a question. And then if they're a good data scientist, they'll end up pushing the manager to why they want that answer, why they need this data. And they'll usually act, I think, as a good kind of blocker of any questions or any kind of things, any kind of work that doesn't need to happen. But I definitely think there just needs to be that open communication, and like we just need to see, what are you trying to do? Like how can we make sure that this data gets to you in the right format? How do you think the role of a data engineer will change moving forward? Responsibility. Right now, I think, I'm trying to think how far ahead. I think for now it's going to continue. Data is going to get bigger. I think that's one of the big things is data is just going to keep getting bigger and more complex and more inclusive of everything, in the sense that almost everything we're going to do is going to basically be tracked by data, right? Like you've got companies like Amazon Go, or Amazon and their Amazon Go store, and now they're creating data basically on watching people walk through a store, and you're going to need to now translate how people walk through a store into data, and then that data then needs to be analyzed. And a lot of that can be video stream, but I'm sure there'll be some of it that ends up being metadata, and you need to manage that. So yeah, I think it's just gonna keep getting more and more complex. I think you are gonna see, I think the one thing I would like to point out is like streaming analytics. So things like Kafka, Spark, I think that's something that's where things are going, just because more and more things we're going to want to see live. And so I think that's a big thing where skill sets are going. Right now it's very limited, I think, for like Spark usage to bigger companies, or companies like Netflix that use a lot of things like, or a lot of streaming things, but I think it'll become more inclusive. Also, who are the people who should not opt for this field? Like the people who will find this field more difficult, and people who, okay, so who shouldn't go into data engineering? I think people who don't like following like rigorous steps. I think data engineering can occasionally be a little less creative than software engineering. I think software engineering allows you that aspect to try to be very creative when you're creating things or creating like systems. Whereas I think data engineering, there's just a good way of doing things. And if you don't like doing it that way, if you want to kind of try to be overly creative, it can be worse. I often like to say, when I open up a pipeline, I can tell if a software engineer has made it, because they have all of these ideas of complexity and object-oriented programming, and that's often not necessary and often bad practice in data engineering. Again, data engineering, we focus on creating isolated tasks, which can sometimes seem like duplication of work, but often kind of plays its own role. So that's kind of where I think there.
Hey, Ben.
Yes.
It looks like we're running out of time, so I'm going to cut you off.
All right. Sorry, guys. I try to get to everyone.
All right. So thank you again, Ben, and thank you, everybody, for joining. If you want more tutorials and content like this, follow us on Facebook, Twitter, Instagram, and LinkedIn. You could also follow Ben at Seattle Data Guy on Twitter. You can also find more tutorials like this available at tutorials.datasciencedojo.com and blog.datasciencedojo.com. Thank you, everyone, for watching, and we'll see you next time.